So the project aims to develop a secure and scalable facial recognition system for residential access control, facilitating user authentication and visitor management. Leveraging enhanced computer vision technologies, the system will employ a combination of hardware components and software modules to ensure reliable identification and seamless user interaction.
So the key users involved in this project are the authorized homeowner and the guest. The authorized homeowner is the user who who is in charge of the account and unlocks the door and then gives access to the guests to enter the house. And the guests are those who submit their facial data by getting the face scanned by the camera in order to have access and to register and to have access into the house.
The node hosting the camera and doorbell is responsible for implementing the facial recognition analysis to be performed on all guests that visit. When the doorbell is pressed, the camera opens and attempts to take an image of the visitor, given there is sufficient light. If the visitor is recognized, the camera node sends an unlock instruction to the lock.
The central node, which is the server, receives, sends, or transmits JSON structured messages from all nodes using UDP protocols and WebSockets. When the message is received, it is transmitted to the node needed and gives a confirmation response.
The lock node is in a constant locked state until the user unlocks it via the website. This leads to it being unlocked for 10 seconds in order for the guest to gain access to the house and then resumed being locked again.
There are two databases, the local database and the cloud database. The local database is a relational database that is written in SQL. The cloud database enables information to be stored on the cloud. The local database consists of fields such as light intensity values, lock and unlock time. These databases are used for storing information of authorized users.
The front end of the website has two specific buttons which are meant to unlock the door and to add a guest face to the system. The backend then implements this by sending UDP datagrams to the central node in order to communicate with other nodes such as the lock node, which then unlocks or locks the lock.
For the light node component, the main parts of it are the LDR and ADC. The light node detects the intensity of the light in the environment and gives recursive feedback to another node to determine the action of the camera. It uses the AO pin of the LDR module to be able to read voltage values, which determines the outcome of the LED.
WebSockets are employed for real-time communication between the server and the other nodes, which are clients. The WebSockets library is used for WebSocket communications.
In order to control the solenoid lock, a relay module must be an intermediary component. This is to control the lock based on a voltage difference. It is important to note the voltage requirements of each device are different. The relay module is 3 volts. The solenoid lock requires 6 volts, and therefore a 6 volt power adapter is required. To unlock the lock, the pin the relay module is connected to is set to a high voltage, i.e. 1, which then activates the relay module's coil. The relay module allows current to flow through upon this voltage high, thus energizing the solenoid lock, which retracts the lock. This mimics unlocking a door. For further detail on the relay module, the signal wire, which is specified by S, and the yellow wire is connected to the GPIO pin 18. It provides the signal to either lock or retract the lock. The V, which stands for voltage, wire is connected to a 3.3 pin and is shown by the red wire. This more or less lines up with the 3 voltage requirement of the relay module, so no level shifting is required. The G, which stands for ground and specified by the black wire, is simply just connected to ground. Moving on to the other side of the relay module, the NO, or normally open terminal, which connects to the circuit when the relay module is triggered, leads to the positive end of the power supply to power the lock. And the COM, which is the center terminal, connects to the lock in order to power it, as shown by the red wire. The COM terminal is what makes the connection to the NO terminal, in this case in order to retract the lock. The ground of the lock also leads to the ground of the power supply, which is shown by the black wire.
So this is the light sensor node. So this component acts as a feedback loop, which means that it continually sends data on the light intensity to determine if the light in the environment is sufficient enough for the camera to take a picture. So I have a component here called a light module. It consists of an LDR. It has 4 pins: AO, which is an analog input pin, analog output; DO, which is digital output; GND, and VCC. So I want to be able to read voltage values. So I made use of an ADC, and also I have the AO connected to channel 0 of the ADC. So what happens is that how the whole thing works is that when light is reflected on the LDR, the resistance on the LDR decreases, which causes an increase in the voltage. So current is able to flow through the circuit, and then it turns on the LED. Then if the light reflected on the LDR is small, or it's of low light intensity, the resistance decreases, and then the current flowing through the circuit also decreases, so the LED turns off. So the ADC enables me to be able to convert all those things to voltage, so I'm able to view those values.
To implement the doorbell, we are using a button from the lab connected to a specific pin on the Pi and ground. A button press represents a visitor ringing the doorbell. From the Python library GPIO 0, we are using class button. Specifying the pin it is connected to and then calling its provided methods is the only other step. In this case, you would specify pin 21 and see that it's connected to ground. So one of our project use cases is unlocking the lock using the doorbell. So all you would do is press the doorbell and then angle the camera towards you, and if your face is recognized, the lock should unlock.
And you can also unlock from the website.
So right now the light intensity is low, that's why the LED is turned on. And based on that, I send the data to the database. So right now it's 15.722, so it's very low, so that's why the LED is on. So our system will basically be able to identify people that we have already put into the database, granting access into the home. Scalability in the sense that we installed a database that will be able to manage how much information we're storing. Then authentication in the sense that we have secure means in which the user can gain access, restricting unauthorized users access into the database or the GUI.
This project, I learned about the various types of documentation required to even begin it. I also realized how important documentation is for tracking purposes and how much more organized you are when you use it.
For my part of the project, I learned the main component of a light sensor and that of an ADC to be able to implement basically the whole light sensor. Also, with in-class concepts and research, I learned how to decide on the best database that is needed for a project requirement.
While working on this project, I've been able to learn the basic workings of a website, the backend and the front end. I've also been able to learn how to implement some basic HTML and JavaScript instructions.
While working on this project, I learned how to make a server for communications using WebSockets and how important IP addresses and sockets are for sending and receiving messages over